This video presents axonometric and oblique projection. Our last video discussed orthographic projection, such as plans, sections, and elevations, wherein the draw plane was set parallel to either the vertical or horizontal planes and aligned with the dominant plane of the object. Axons and obliques share one important property with these earlier types. The projection rays are parallel to one another. Any drawing that holds this property may be described as parallel projection, so we could describe plans, sections, elevations, and axons and obliques all as parallel projection drawings. However, unlike orthographic projection drawings, in axons and obliques, the draw plane is set in no specific relationship to any dominant plane of the object depicted. This allows us to produce three-dimensional views of objects that retain properties that are important to architectural design. For example, any edges of the object which are parallel to one another will appear parallel in our axonometric. And this allows us to compare the sizes of things that would otherwise be distorted in perspective. So things that are far away, that are the same size as objects that are close, appear to be the same size in an axonometric. It's worth noting that if the draw plane of an axonometric is aligned with a major plane within the object, then you basically arrive at an elevation. So we could think of plans, sections, and elevations as a sort of a special case of axonometric. As such, it is actually legal, although a bit unusual, to extend the idea of the section into the axonometric and intersect the cut plane of the axon with the object itself and obey all the rules of taking a section in the process. So you might be wondering what the difference between axons and obliques is then. The answer is very simple, but it might seem a bit unusual at first. In axons, projection lines are perpendicular to the draw plane, while at obliques, they are not. So why on earth would we want this? Well, it turns out that when oriented properly, that oblique drawings allow us to measure both true distances and true angles for any one set of parallel planes in our object. So this can be useful, for example, orienting an oblique such that the plan remains true while the section is distorted, which would allow us to draw in real scale and plan and still depict our object in 3 dimensions. So there you have it, a quick rundown of axons and obliques. Hope this has been helpful.